In this lecture, we will move on to very simple topics. The first one is types of fluid. Fluid, you all know what is the definition of fluid. Fluid is a substance that continuously deforms under an applied shear stress or any external forces. So, all gases and liquids come under the category of fluids. There are different types of fluid: ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, incompressible fluid, and compressible fluid. So we'll move on to each of them. First one is ideal fluid. A fluid which does not possess any viscosity and a fluid which cannot be compressed can be explained as ideal fluid, but it is just an imaginary fluid which does not exist in reality. Okay, because all fluid possess some kind of viscosities and all fluids are somewhat compressible. So an ideal fluid is just an imaginary fluid. Second one is a real fluid. All the fluids are real because all of them possess some viscosity. A real fluid is a fluid which possesses some kind of or some sort of viscosity. And the third one is ideal plastic fluid. When the shear stress is proportional to the velocity gradient and it is more than the yield value, that kinds of fluids are known as ideal plastic fluid. I will explain it with the help of a figure. Here you can see a figure, the velocity gradient at the x-axis and shear stress in y-axis, and you can see a purple line which shows the ideal plastic fluid. Here you can see in this case, in this figure, the shear stress is directly proportional to velocity gradient, shows a very straight inclined line. So ideal plastic shows a very straight inclined line which shows that shear stress is directly proportional to velocity gradient. But the line started from, it is not starting from zero, it is starting from a point which is known as the yield value. Yield value is the minimum value of shear stress for a fluid. Okay, so that type of fluids are known as ideal plastic fluids. Now we will move on to Newtonian and non-Newtonian fluid. So Newtonian and non-Newtonian fluid are classified based on a particular law known as the Newton's law. Newton's law of viscosity. The Newton's law of viscosity states that the shear stress is directly proportional to the shear rate of shear deformation. The rate of shear deformation. And for removing the proportionality, we are giving a constant here. It is dynamic viscosity. So shear stress is tau. Tau is directly proportional to du by dy, which is the rate of shear deformation. For removing the proportionality, we are giving a constant here, that is the dynamic viscosity mu. Okay, so this is known as Newton's law of viscosity. Whichever fluid which is following these law, which is obeying these law, is known as Newton's or Newtonian fluid. And when some fluids which does not obey this law, that type of fluids are known as non-Newtonian fluids. Here in this figure you can see when the shear stress is directly proportional to shear gradient or velocity gradient or rate of deformation, that types of fluids are given as a straight line, and that types of fluids are known as Newtonian fluids. If it is not obeying the law, it is given as a curved line and it is non-Newtonian fluid. Now the other two kinds of fluids are incompressible fluid and compressible fluid. This categorization is based on the density of the fluid. When the density of the fluid does not change with the application of an external force, they are known as incompressible. And when the density of the fluid changes with the application of an external force, it is known as compressible fluid. Now there are different types of fluid flow. You all know that fluid will flow. Okay, there are different types of fluid flow. Here are the different types: steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flows, 1, 2 and 3 dimensional flows. So these are the different types of fluid flows. We will move on to each of them. So the first category is steady and unsteady flow. Steady means with time it is uniform. With time it is uniform. That is known as steady. That is the flow in which fluid characteristics like velocity, pressure, density, etc. at a point does not changes with time. Okay, with time it is not changing, then it is steady flow. Velocity, pressure and density are different characteristics of a fluid, and if these characteristics are not changing with time, then that types of flows are known as steady flow. So we can write it in the form of an equation as dou v by dou t is equal to 0, dou p by dou t is equal to 0, dou rho by dou t is equal to 0. Change in pressure, change in velocity, change in density, everything is 0 with respect to time. And in case of unsteady flow, vice versa, because its properties like velocity, pressure and density will change with respect to time. That is dou v by dou t not equal to 0, dou p by dou t not equal to 0, and dou rho by dou t not equal to 0. So this is the case of steady and unsteady flow. Now uniform and non-uniform flow. This categorization is based on the space. Okay, space. The flow in which velocity at a given time does not change with respect to space, that is known as uniform flow. You can just imagine an example of a small channel. In the small channel, it has the same rectangular shape, as a rectangular shape all through its length. When the fluid is flowing through that rectangular channel, if its shape is very much uniform, then that type of flow is known as uniform flow, because its properties will not change with different places. Properties like pressure, velocity and density will not change at different positions in the channel. That type of flow is known as uniform flow. If it is changing with respect to different positions in the channel, then it is known as non-uniform flow. The channel has some difference in shape. For example, if it is coming as rectangular and if it is diverging like a small trapezoidal channel, then that flow will not be uniform. It will be non-uniform flow. So in case of uniform flow, we can say that dou v by dou s is equal to 0, where dou s is the space, change in space, change in velocity with respect to space. And in case of non-uniform, dou v by dou s not equal to 0. Similarly, dou p by dou s is equal to 0 for uniform, and dou p by dou s not equal to 0 for non-uniform. So here is an illustration of uniform and non-uniform flow. I have already told you that there is a rectangular channel which is uniform in size, then the flow will be uniform there. And another channel which is not rectangular, which is just like diverging stream, then the flow in that channel will not be uniform, it will be non-uniform. Okay, in case of steady flow, with respect to time it is not changing. With respect to time, if it is changing, that type of flow is known as unsteady flow. This is a simple illustration of that two kinds of flows. Now the next category of types of flow is laminar and turbulent. So laminar flow, the flow in which the adjacent layer does not cross to each other and move along the well-defined path, is known as laminar flow. You just imagine a small channel in which water is flowing up to a height of 5 centimeter. Okay, so water is flowing up to a height of 5 centimeter. Water will always flow. All the fluids will flow in layers. Okay, we cannot see the layers by our naked eyes, but even though it is flowing in layers. So at 5 centimeter there will be a layer, 4.9 centimeter there will be a layer, 4.8 centimeter there will be layer. If all these layers of water are not crossing their paths, they are flowing in their own path, straight paths, then that kind of flow is known as laminar flow. If they are crossing their paths, then that kind of flow is known as turbulent flow. So in the laminar flow, the motions of the particles of the fluid is very orderly, with all particles moving in straight lines parallel to the pipe walls, parallel to the channel. But in case of turbulent, it will not be parallel. Its path, the path of each of that layers will be changing, and it will cross each other. So that is known as turbulent flow. We can explain this laminar and turbulent flow by means of a figure. This figure you can see, in case of laminar flow, all the layers will be passing in a parallel line and it will not cross each other. In case of turbulent, it will be crossing each other in a turbulent manner. We can categorize these flows into laminar and turbulent based on a particular term known as Reynolds number. You all may have heard of this. Reynolds number is used as a criterion for classifying the flow as laminar and turbulent. Reynolds number is a non-dimensionless number, dimensionless number, which is equal to V d rho by mu. V is the average velocity, which is expressed in meter per second. D is the pipe internal diameter, which is expressed in meter, and rho is the liquid density, which is expressed in kilogram per meter cube, and mu is the dynamic viscosity, which is expressed in kilogram second per meter square. So based on the Reynolds number, we can categorize these flows into laminar, turbulent, and some other things. So we will see that this here is the classification. When the value of Reynolds number is greater than 4000, then that kinds of flow are known as turbulent flow. And when the Reynolds number is less than 2000, that kinds of flow are known as laminar flow. And when the value of Reynolds number is between 2000 and 4000, then that kind of flow is known as transitional flow. So these categories of Reynolds number is based on is applicable in case of pipe only, pipe flow. In case of pipe flow, if it is greater than 4000, it is turbulent. If it is less than 2000, it is laminar. If it is between 2000 and 4000, then it is transitional flow. Okay. Another category of flow is compressible and incompressible. So this we have already seen in the types of fluids also. The same thing. When the density changes with the application of pressure, it is known as compressible flow. When the density of the fluid does not change with the application of pressure, it is known as incompressible flow. Here we have seen, we can see the figure, and you can see the illustration in the figure. We are applying pressure P1 and P2, where P2 is higher than P1, even though the flow is not changing. The density of the flow is not changing, then that type of flow is known as incompressible, which is shown in the left figure. And in the right figure, if we are applying P2, which is greater than the normal pressure, what will happen? The flow will get compressed. The density will get decreased and the flow will get compressed. That type of flow is known as compressible flow. Another category of flow is rotational and irrotational flow. So rotational flow means all the particles in the flow are rotating about its own axis, or some of the particles in the fluid are rotating about its own axis, while in irrotational flow, none of the particles are rotating about its own axis. We can illustrate it by means of a figure. Here is a figure. In this figure, the topmost fluid particles are not rotating in their own axis, so they are irrotational, and in the lowermost particles have some extra pressure and they are rotating by their own axis, so they are known as rotational flow. And the final type of flow is 1, 2 and 3 dimensional flow. It is very simple. The flow in which the velocity is a function of time and one space coordinate is called one dimensional flow. The flow in one dimension. So if velocity is u, then it will be dependent on x axis only. Then that type of flow is known as one dimensional flow. In y and z direction, the velocity will be 0. In case of two-dimensional flow, the flow will have velocity in x and y direction. It will not have any velocity in z direction. In case of three-dimensional flow, the flow will have velocities in all the three directions. Normally, in normal cases, fluid flow will be three-dimensional, but we are taking it as one-dimensional or two-dimensional to get it in a simple way. To get the equations and all the derivations in a simple way, we are taking it as 1D or 2D flow. Okay, normal flows are three-dimensional only. So with this, all the type of flows we have completed. Now we will move on to a different topic: path line, streamline, and streak line, which is very much important in fluid flow. So path lines. Path line is a path or trajectory traced out by a fluid particle. Here you can see, by the help of a figure I will explain. So here you can see four particles of fluid. Four particles of fluid flowing from a pipe or something. Okay, blue is a particle, red is a particle, green is a particle, and yellow is a particle. Different particles of fluid. So the blue particle, at time t0 it was inside the pipe, and at time t1 it comes out of the pipe. At time t2 it has moved some distance far away. T3 it has moved again some distance, and like that. So that is the trajectory or path of the blue particle. Okay, so that is the, we can say it as the path line of the blue particle. And similarly, the second one is the path line of green particles. Below that there is a path line of red particle, and below that there is a path line of yellow particle. So path lines are the path or trajectory traced out by a single fluid particles. Okay. Now streamline. Streamline is just an imaginary line that is imaginary line in which imaginary line which we are drawing along the tangent of the velocity vector. Along the tangent of the velocity vector. The fluid particles will have velocities. Okay, the fluid particle, each of the fluid particles will have velocities. If we are drawing a tangent to the velocity, and joining all that tangents together, then that is equal to streamline. It is just an imaginary line. Streamlines actually show the directions of the fluid element at any instant of time. At a particular time, what is the direction of that fluid particles? That is shown by using streamlines. This can be explained by means of an equation. du by u is equal to dv by d is equal to dw by t w. Okay, where u, v, and w are the velocity components in x, y, and z directions respectively. And a bundle of streamlines together are known as stream tube. If you are taking a bundle of streamlines together, then that is known as stream tube. And the last type of lines are streak lines. Streak lines concentrate on fluid particles that have gone through a fixed station or point. At a particular time, we are fixing a particular point. So all the fluid particles, the line of all the fluid particles which are moving through that point is known as streak line. At some instance of time, the position of all these particles are marked and a line is drawn through them. Such a line is called streak line. So you can see here, at time t0 all the particles were inside that pipe. At time t1, yellow has reached a particular position, red has reached a particular position, green has reached a particular position, and blue has reached a particular position. If you are drawing a similar line, a line between all these particles, then that line is known as streak line. So here, in case of a steady flow means the properties of flow is not changing with respect to time. In case of a steady flow, all these three lines will coincide. All the three lines will be the same. Here we can see the example of a steady flow. The velocity vectors, first figure shows the streamline. All the velocity vectors are going in the same way. Okay. The second thing shows a streak line. Streak line means lines connecting a particle generated from a particular position. So in this case, there are four tubes. the uppermost line shows the particle generated from the uppermost tube, and the lowermost line shows the particle generated from the lowermost tube. So all these lines are streak lines, so it is similar to velocity, I mean streamlines. Now the third one is path line. Path line is the trajectory of a particular fluid particle, so it is similar to the previous one, streak line and streamline. So this is in case of a steady flow. In case of unsteady flow, all the three lines will be different. And the important points to be noted are, in a steady flow, the streamline, path line and streak line all coincide. For an unsteady flow, they will be different and will be showing different trajectories. And streamlines are easily generated mathematically, while path line and streak lines are obtained through experiments. And another important point is timeline. Timeline is a line through adjacent particles in a flow at any instant of time. We are joining all the particles through a flow. That is known as timeline. It is just similar to that of path line. Okay. Thank you.